You've heard a Gardner engine, even if you never knew its name. If you rode a bus outside London, ate fish landed at Hull or Grimsby, or walked past a generator at any travelling fair in Britain, you heard one. That deep, unhurried chug, slow and steady and utterly unlike anything else on the road. At its peak, Gardner of Patricroft employed 2,800 workers building the most fuel-efficient diesel in the world, each engine polished to a mirror finish before it left the works. They survived 2 world wars, survived the Depression and the oil crisis, powered the midget submarines that crippled the Tirpitz and the launch that carried Churchill's coffin down the Thames. And then, after 126 years of making, the works went silent. How does a company that survived all of that simply disappear? What happened inside those walls? Chapter 1. The Cellar on Upper Duke Street. The story begins, as so many British industrial stories do, with something absurdly small. In 1868, in 4 back-to-back cottages on Upper Duke Street, off Stretford Road, in the crowded inner-city parish of Hulme, Manchester, a young man named Lawrence Gardner set himself up in business. He was 28 years old. He had no formal education that anyone later recorded. He had a wife, Anne née Kynaston, a miller's daughter from Liverpool, like himself, the child of the working trades. He had a common cellar shared between all 4 dwellings, and he had, this is the detail that tells you everything about the man and everything about the company he would build, a 10.5-inch lathe and an 8-foot boiler that he'd lowered through the pavement trapdoor on planks suspended from a bedroom window above, because neither piece of machinery would fit through any of the doors. The paving stones bent under the weight. Every account of the firm's founding records this, because it so neatly anticipated the character of the company Lawrence Gardner would leave behind, solid, ingenious, and quietly contemptuous of anything that looked like the easy way round. He called himself L. Gardner, machinist. It was the lowest rung of the engineering trades. Not a manufacturer, not an iron founder, not a mill owner or a locomotive builder. A machinist, a man with a lathe and a boiler, taking whatever subcontract work the wider Manchester economy put in front of him. He lived in one cottage with Anne, let the other 3 to tenants, and worked below them all in a cellar that smelled of cutting oil and iron filings and the particular damp of a Manchester basement that never quite dried out. His origins were as modest as the workshop. Lawrence Gardner had been born in Liverpool in 1840, the second of 5 children to Thomas Gardner, a man variously described in census returns as a labourer in 1841 and as a miller in later family tradition. The discrepancy has never been resolved. Both versions have been published, and both say something true about the class of people from which Lawrence came. His father Thomas died in the late 1840s, leaving Lawrence's widowed mother Jane to raise 5 children through the Liverpool of the post-famine years, a city then absorbing hundreds of thousands of destitute Irish refugees, its docks overwhelmed, its cellars overflowing with the desperate and the dying. Whatever schooling Lawrence received in that environment, none of it was recorded. What was recorded was that by 1861 he had married Anne Kynaston, and by 1868 they had moved across Lancashire to Manchester. The move tells you something about Lawrence Gardner's instincts. Liverpool in the 1860s was a city of commerce, of shipping, of the warehouse and the counting house. Manchester was a city of making, of lathes, of hammers, of the forge and the foundry. A man who wanted to move goods chose Liverpool. A man who wanted to make things chose Manchester. Lawrence Gardner wanted to make things, and the engineering trades offered a man with strong hands and a good eye, something that Liverpool's docks could not. A path upward that didn't depend on who your father was or which school you'd attended. When his tenants defaulted on the rent and the landlord threatened to seize Gardner's tools, which were all that was of value under those roofs, Lawrence took out a building society loan at 31 shillings and 6pence weekly repayment, roughly £1.57 in decimal, and bought the 4 properties outright. It was a bold move for a cellar machinist with no capital and no connections. The tools survived. The workshop stayed open. The work continued. But collecting weekly rents of 3 shillings and 6pence to 6 shillings and 3pence from his own tenants was, by all accounts, an embarrassment Lawrence Gardner never quite shook. The Hulme he had chosen was one of the most concentrated pieces of engineering infrastructure in Europe. Within walking distance lay the Bridgewater foundry of James Nasmyth, the firm that gave Britain the steam hammer. The Crossley Brothers engine factory sat at Openshaw. Byer Peacock's locomotive works hummed at Gorton. The Bridgewater Canal ran through the district, feeding the cotton mills of North Manchester and Salford, and the still young Manchester-Liverpool Railway connected the whole to the docks and the world beyond. Cotton was king. Manchester's cottonopolis identity was at its peak in the 1860s, but the secondary engineering trades that served the mills had grown into a formidable industrial base of their own. Machine tools, dynamos, valves, gears, belting, pumps, a dense thicket of small subcontract shops, each feeding the next, all feeding the insatiable appetite of King Cotton. Lawrence Gardner slotted himself into that thicket with nothing but a cellar, a lathe, and a willingness to make whatever anyone would pay him to make, and what they paid him to make was everything. Sewing machine parts, rubber tire molds, bread dough mixers, dentists' chairs, some hydraulic, some rack and pinion, 106 of them in the first 3 years after the firm moved to larger premises on Lund Street, and at least 2, reportedly still in clinical use, locally within living memory. Platinum wire denture rivet cutters, a coffee roaster consisting of 4 horizontal drums suspended over a gas flame. If an engineer in late Victorian Manchester needed something precision-made from metal and couldn't find it off the shelf, Lawrence Gardner would make it. There was no buying in of part-finished components. Gears were cut from brass by hand and filed to such accuracy that they could serve as the masters for castings. This meticulous approach, finishing work correctly, not to a price, not to a deadline, but to a standard that existed only in the maker's own head, was the cultural DNA that the first generation planted and the second generation would inherit wholesale. It would become the firm's greatest strength, and in the end, transmuted into something harder and more dangerous, it would become the thing that killed it. Grace's Guide, the engineering encyclopedia, observes that Gardner's early trajectory ran almost exactly parallel to that of Henry Royce, both founders, the sons of millers, both businesses starting off Stretford Road, both driven from their first trade, electrical dynamos, by cheap American imports flooding the British market in the 1890s, both pivoting to the products that would make them famous, both, in the end, coming to dominate the quality end of their respective markets. The difference is that Royce got a peerage, a brand, a winged lady on the bonnet, and an immortality that transcended the engineering trade entirely. Lawrence Gardner got none of those things. He died in 1890, at 50, before any of the engines that would carry his name had even been imagined. He never saw a Gardner engine. He never heard one run. He never knew that the precision culture he'd built in a cellar, the insistence on filing brass gears by hand until they sang, the refusal to buy in what could be made better in-house, would one day produce the most thermally efficient automotive diesel in the world. He died a cellar machinist who'd made dentists' chairs and coffee roasters and brass gears filed to perfection, and left behind a widow, a small but growing firm, 5 sons, and a name that would outlast all of them by more than a century. His eldest son, Thomas Harry, was nearly 30 when the old man died. He'd clashed with his father over Lawrence's lack of education. Thomas had worked away from Manchester through the 1880s, putting distance between himself and the cellar. But when his father died, he came back. He took the firm forward alongside his mother Anne and his brother Edward, and he made a decision that tells you something about the respect that ran through that family, even when the arguments ran hot. When the firm incorporated as a limited company in 1900, the brothers kept the founder's name. Not Gardner Brothers, not T.H. Gardner and Co. They kept L. Gardner and Sons, the dead man's initial on every letterhead, every casting, every engine that would follow for the next 94 years. By 1891, the operation had moved from the cellar to Lund Street and employed 80 men. Then came Cornbrook Park Road. Then, in 1899, the move that would define the company for almost a century. Thomas Harry Gardner bought land at Patricroft. Chapter 2. 5 Sons and the Dead Man's Name. Patricroft sat at the junction of 3 transport revolutions, and Thomas Harry Gardner knew exactly what he was buying. The Bridgewater Canal, opened in 1761, the canal that had launched the Industrial Revolution itself, ran along the southern edge of the new site and could deliver coal and coke from the Wigan and Lee coalfields directly to the works by barge. The Manchester-Liverpool Railway, opened in 1830, ran along the eastern boundary. Patricroft Station, designed by George Gilbert for George Stephenson's Liverpool and Manchester Railway, was one of the oldest surviving passenger stations in the world, and its good sidings could move finished engines and personnel to the docks at either end of the line. And the Manchester Ship Canal, opened just 5 years earlier in 1894, connected the whole district to the ocean. 3 waterways worth of raw materials in, a railway's worth of finished products out, and an ocean-going canal to carry the name Gardner to any port that would have it. Within a mile of the new site lay Nasmyth's Bridgewater Foundry, the Eccles spinning mill, built in 1906 by Joseph Schofield, the mayor of Eccles, and a string of cotton mills running along the canal and into Worsley. The labour market was deep, skilled and battle-tested. Generations of fitters, turners, pattern makers, smiths and erectors had been bred on foundry work, railway maintenance and textile machinery repair. These were not unskilled hands. These were men who could read a micrometer, swing a hammer to within 1/1000 of an inch, and argue the merits of a casting over a pint at the end of the shift. Gardner inherited this workforce culture wholesale, and it would define the character of the works for the next century. The new premises were called Barton Hall Engine Works, named for the old Barton Hall that had once stood nearby on the banks of the canal, and the works was designed around a single principle that would both define and eventually constrain the firm. Every operation that could be done in-house would be done in-house. Pattern making, iron casting, crankshaft turning, fuel pump assembly, final test. The integrated foundry was unusual for a firm of Gardner's eventual size, but the in-house manufacture of fuel injection equipment, the precision heart of any diesel engine, the component that determines combustion timing, fuel metering and spray pattern to tolerances measured in microns, was almost unique in British engineering. Perkins didn't make its own injectors. Leyland didn't. Cummins didn't. Gardner did, because Gardner believed that if you wanted something done properly, you did it yourself, and if that made you slower than your competitors, so be it. Eccles itself in 1900 was a borough of about 35,000 people, formerly separate from Manchester until the local government reorganisation of 1974. It had its own mayor, its own town hall, its own civic identity rooted in liberal nonconformism. The religious culture predominantly Methodist and Anglican, with substantial Irish Catholic populations around Patricroft and Weast, who had arrived in the waves of migration that followed the famine and never left. The Eccles cake, the small currant pastry, was the borough's national export. Gardner would become, within a generation, the town's largest employer and a defining piece of its identity, in the same way that Byer Peacock defined Gorton or the Royal Ordnance Factory defined neighbouring Trafford Park. Families that sent their sons through the Barton Hall gates at 15 would still be sending grandsons through those same gates 40 years later. The works and the streets around it became a single organism, breathing to the rhythm of the shift pattern. The engines themselves arrived in stages, not in any single flash of revelation. The Robinson hot air engine came first, manufactured under license from 1894, after the design by A.E. and H. Robinson was described in the Illustrated Magazine of Practice and Theory in November 1891 as a useful and thoroughly good motor for driving small machinery. The Robinson weighed 1,200 in weight, had a 10-inch bore and 10-inch stroke, developed 5/8 of a horsepower at 170 revolutions per minute, and ran on coke burned in its firebox at 7.5 pounds per hour. Its thermal efficiency, the proportion of energy in the fuel that actually became useful work, was somewhere between 7 and 10%. 90% of the energy in the coke went to waste. It was, by any later standard, a spectacularly inefficient machine. But it ran, and it ran, and it ran. One pre-1900 example, recovered decades later from a farm in Horsham, Sussex, had pumped water continuously and without attention until frost damaged it in the severe winter of 1958. 60-odd years of unattended service from a single engine. Gardner longevity was already a brand, even before anyone at Barton Hall had heard the word diesel. The Type 0 followed in May 1895, a single-cylinder horizontal gas engine rated at half a horsepower at 450 revolutions per minute for domestic pumping and workshop drives. By 1897, the firm was making oil engines. By 1903, it had built its first diesel proper. The same year, Norris and Henty Lentide of London was appointed as exclusive sales agent. a joint sales subsidiary, Norris, Henty and Gardner's Ltd., was formed in 1912 and would handle the firm's distribution for half a century, and with the diesel came the product ranges that would carry the Gardner name across Britain. The M-Series marine engines ran from 1902 to 1933, from the little 1AM at 3 brake horsepower up to the 6SM at 200. The V-Type, from 1903 to 1935, served domestic lighting and pumping. The R-Series arrived in 1906. The F and H horizontal engines came in 1910. The VT range of 1913 was a hot bulb semi-diesel, a transitional technology halfway between the old oil engine and the true compression ignition diesel. The heavy industrial HF range appeared in 1926. Each successive range was a refinement of the one before. Each was built to the standard Lawrence had set in the cellar, gears cut by hand, filed to accuracy, finished to a tolerance that existed in the maker's judgment rather than on a printed specification sheet. But none of this, not the Robinsons, not the gas engines, not the M-Series Marines, not the HFs, was the product that would make the name Gardner mean something to every truck driver, every bus conductor, every trawlerman in Britain. That required a leap, and the leap, when it came, arrived in the most unlikely form imaginable: a bus with the wrong engine. Chapter 3. The Engine That Found the Road. In 1929, a customer asked Gardner to drop a Marine 4L2 engine into a Lancia bus chassis. It was an improvisation, an operator who wanted diesel economy in a passenger vehicle and couldn't find anyone in Britain building a suitable road engine, so he took a boat engine and put it in a bus. The chassis groaned. The conversion was rough, but it worked, and it worked so well that it changed the trajectory of the entire firm. What the Lancia conversion proved was something the Gardner family had not expected. A marine diesel, designed for sustained running at steady load in the hull of a fishing boat, turned out to be perfectly suited to the sustained running at steady load demanded by a bus on a fixed route. The operating economics were transformative. Diesel fuel was cheaper than petrol per mile. The engine's thermal efficiency was vastly superior to any petrol unit of comparable size, and the durability margins built into a marine specification, designed for thousands of hours at sea between overhauls, meant that road-going service barely stressed the engine at all. A marine engine asked to haul a bus was like a cart horse asked to carry a child. It didn't even notice. The conclusion was obvious. Gardner committed to a purpose-built road engine. The LW series, lightweight, launched in 1931. Graham Edge, the firm's principal historian, and Gardner's own subsequent literature, would claim it as the world's first small high-speed direct-injection diesel engine purpose-built for road vehicles. Whether that claim survives rigorous international scrutiny is debatable. Mercedes-Benz and MAN were working similar ground in Germany at the same time. But what is not debatable is that the LW was the first such engine to establish complete commercial dominance in a national market. Within 5 years, it had become the prestige heavy vehicle diesel in Britain. Not the cheapest, not the most powerful, the best. The design was characteristically Gardner, modular, logical, and built to be serviced by anyone with a set of spanners and a clear head. Cast-iron cylinder blocks and heads came in 2- and 3-cylinder modules, so a 5-cylinder 5LW was a 2 bolted to a 3, and a 6-cylinder 6LW was either 2 3s or 3 2s. The automotive crankcase was aluminium alloy for lightness. The marine crankcase was cast iron for corrosion resistance. The 4LW gave 75 brake horsepower at 1,700 revolutions per minute from 5.5 litres. The 5LW gave 85 horsepower from nearly 7 litres. The 6LW gave 102 from 8.3 litres. Later up-ratings, marketed as the Gardner 100 and Gardner 120, raised those figures to 94 and 112 respectively. Each step was a worked refinement of a proven layout. Nothing was thrown away and started fresh. Nothing was designed to be fashionable. Everything was designed to last. The customers came in a flood. Crosville Motor Services specified the 5LW and 6LW for its bus fleet across North Wales and Cheshire. Bristol Tramways followed. Northern General, the Tilling Group, which controlled a vast network of provincial bus companies. North Western Roadcar, Ribble. Most of the northern municipal operators specified Gardner, and many AEC, Bristol and Leyland bus chassis left their builders' works without engines, to be collected from Patricroft already fitted with Gardners on the operating company's insistence. Nobody was forcing them. The chassis makers offered their own power units. The operators chose Gardner anyway, and paid the premium, and waited for delivery, and considered neither cost nor delay a reason to settle for anything less. A Crossville Bristol K with a 5LW was, by 1938, the gold standard of British provincial bus operation. The lorry trade followed: Foden, Atkinson, Sentinel, Albion, Guy, Dennis, Bristol, ERF, and a dozen smaller assemblers. But the most dramatic convert, the man whose story would become inseparable from Gardner's own, was Edwin Richard Foden. Edwin was a sandbach man, born into the family that had built Foden Laiteed into one of Britain's most respected manufacturers of steam wagons. By the early 1930s, he was in his early 60s and had spent his entire working life building steam. But he could see what the Gardner LW meant for the future of road haulage. He tried to persuade the Foden board to abandon steam traction and embrace the diesel. His brother William, known as Billy, eventually governing director of the firm and destined to live to 96, and the rest of the board refused. The argument was fierce, personal, and final. Edwin, furious, left the family firm that bore his name. In 1933, at the age of 63, he founded a new company and gave it his initials, ERF. His son Dennis joined him. Ernest Sherratt came on as chief engineer. The local coach builder John Henry Jennings of Sandbach built the first cab, and chassis number 63, Edwin's age, rolled out of a small works a stone's throw from the Foden factory, carrying a Gardner 4LW engine, a David Brown gearbox, and Kirkstall forge axles. ERF's entire pre-war identity was built around Gardner power. The model designation system, CI4 for compression ignition 4-cylinder, CI5, CI6, explicitly named the Gardner cylinder count on every chassis plate. From its first day of existence, ERF existed because Gardner existed. The two firms' fates were lashed together by a 63-year-old steamman's anger at his own brother, and they would remain lashed together for decades to come, through prosperity, through war, through the long mutual decline that neither firm saw coming. Even the luxury market took notice. Small numbers of 4LWs and 6LWs were fitted by specialist coach builders to Bentleys, Rolls-Royces and Lagondas in the 1930s. One converted 2-ton Bentley achieved a documented 30 miles per gallon with an 80-mile-per-hour top speed, a combination of economy and performance that no contemporary petrol engine could match. It was a party trick, not a market, but it proved something the trade press loved to repeat. A Gardner could do things no other engine could do, and do them with a refinement that bordered on the aristocratic. Marine orders poured in from the fishing fleets at Fleetwood, Hull, Grimsby, Aberdeen, and Newlyn. Canal narrowboats adopted Gardner as standard, harbour tugs, naval pinnaces, private yachts. By the early 1960s, an estimated 83% of new British-built fishing vessels would be Gardner-powered, with roughly 45% of total Gardner output going to fishing boats and 59% of those exported. The fish and chips that fed the nation came home in boats that ran on Patricroft iron. By the end of the 1930s, the workforce stood at 2,800, producing about 3,500 engines a year, on a site covering more than 30,000 square metres, roughly 7.5 acres of buildings. It was the largest the works would ever be. Multi-generational employment had already become normal. The surrounding Patricroft and Eccles streets fed fathers, sons and uncles into different shifts and different shops, with apprenticeships running 5 to 7 years from the age of 14 or 15, handed down within families like a tenancy or a trade. The work school of engineering was internal and informal, but demanding beyond what any technical college could match. A young man named Hugh Gardner, grandson of the founder, nephew of the current directors, started in the number 10 test shop in 1921 at 14 shillings a week. He raced Nortons at Southport Sands with his brother John. He ran an Invicta car converted to take a light alloy Gardner 6LK engine, a serious piece of automotive engineering, not a weekend hobby, but a statement of faith in what the family made. He would learn the trade alongside the men he would one day chair. He would, in time, design the finest diesel engine ever built. And then, decades later, he would be the man who killed everything they'd built, not through malice, not through greed, but through a conviction so deep it became indistinguishable from arrogance. But that reckoning was 40 years away. First, there was a war to win. Chapter 4. The Submarine and the Searchlight. The First World War had already given Gardner a taste of military production. The firm was one of 9 contractors, alongside Tanguy, Crossley, Peter Brotherhood, Browett Lindley, National Gas Engine, British Westinghouse, Willans and Robinson, and Perkins, awarded contracts to build the Ricardo 150 horsepower petrol engine for the Mark V tank. Over 5,000 Ricardo engines were ordered across all the contractors for the Mark V program. Gardner's individual share was never publicly separated, but the works expanded sharply to handle the contract, and the wartime experience of running a precision production line under government supervision built capabilities the firm would deploy again 20 years later. The Second World War demanded something different. Instead of being handed someone else's drawings and told to mass-produce them, the standard munitions model that converted piano factories into shell fillers and biscuit works into bomb case stampers, Patricroft spent most of the conflict building its own designs. Standard LW diesels powered army lorries, RAF airfield generators, anti-aircraft searchlight sets, and fire pump installations across Britain and the theatres of war. The civilian truck market was effectively shut down for the duration. Because Gardner engines were prioritised for military use, commercial truck makers, including ERF, were forced onto substitute power plants. AEC 7.7-litre units, competent but not Gardner. ERF's wartime model designation changed from CI, compression ignition, meaning Gardner, to DI, diesel injection, meaning AEC. The entire customer-facing nomenclature of Britain's most Gardner-dependent truck maker shifted around the absent engine. A single letter changed on the chassis plate, and everyone in the trade knew what it meant. The Gardners had gone to war. But the engine that earned Patricroft a permanent place in British military history was not the LW. It was the smaller, quieter, more compact 4LK. The 4LK was a naturally aspirated 4-cylinder diesel, 60 brake horsepower from 3 8/10 litres. Gardner had designed it in the mid-1930s for buses, specifically for underfloor installation in municipal single-deckers, where space was tight, noise was unwelcome, and reliability was the only specification that truly mattered. It was light enough for a strong man to feel the weight of it in the floor beneath his feet, but not complain about it. It was compact enough to fit under a gangway. It started without fuss in the cold. It ran for days at a time without complaint, and it could absorb physical punishment that would crack the castings of a lesser engine. These were precisely the qualities the Royal Navy needed for its midget submarines. An X-craft was 48 feet long. Its crew was 4 men. There was room for exactly 1 compact diesel to charge the batteries and run the boat on the surface, and that engine had to meet requirements that no other application in British engineering demanded simultaneously. It had to be reliable in the most absolute sense of the word. A mechanical failure in a midget submarine operating behind enemy lines in a Norwegian fjord was not an inconvenience to be resolved by the breakdown service. It was a death sentence for 4 men in a steel tube 60 feet below the surface of a freezing sea. The engine had to start in sub-zero temperatures without hesitation. It had to run quietly enough not to alert German hydrophone operators listening for exactly this kind of intruder. And it had to survive the physical shock of depth-charge concussion, the savage hammering of underwater explosions that could shatter a conventional casting like a teacup dropped on a stone floor. The 4LK, a Patricroft bus engine designed for the 7.15 to Warrington, met every one of those requirements. In September 1943, 6 X-craft were deployed in Operation Source against the German battleship Tirpitz, then sheltering in Kafjord in northern Norway. The Tirpitz was the Royal Navy's nightmare, a 42,000-ton capital ship that simply by existing in a Norwegian fjord tied down the entire home fleet and threatened the Arctic convoys carrying war material to the Soviet Union. Destroying or disabling her would free the fleet. 3 of the 6 X-craft reached the target. Their crews, Lieutenant Basil Place, commanding X-7, and Lieutenant Donald Cameron, commanding X-6, navigated minefields, anti-submarine nets, and German patrol boats to lay explosive charges beneath the battleship's hull. The resulting detonations put the Tirpitz out of action for 6 months, a strategic achievement of the first magnitude. Both Place and Cameron were awarded the Victoria Cross. Later, XE-class boats, the improved variant built for the Pacific War, attacked Japanese shipping in the Straits of Johor and the approaches to Singapore, cutting telegraph cables and mining harbour approaches in operations that contributed to severing Japan's supply lines in the final months of the conflict. The engine that took those men into the fjords, that started in the dark, that charged the batteries, that drove the propeller and kept 4 men alive in a space barely wider than a coffin, was a Gardner 4LK, built in Patricroft by the grandsons of a cellar machinist from Hume. 2 Victoria Crosses, one in boats powered by a municipal bus engine. The Admiralty never forgot it, and neither did the trade. The war hardened Gardner's reputation into something close to an article of faith. If a 4LK could run in a midget submarine under depth charge attack, it could run in anything. If the Admiralty trusted Patricroft iron with the lives of its most daring sailors, a bus operator in Birkenhead could certainly trust it with the evening service to Chester. The commercial reputation that Gardner had built through 2 decades of LW sales was now battle-tested, and the post-war market would treat it accordingly. Peace came, and with it the largest boom the British road haulage and bus industries had ever seen. Long-distance trunking expanded massively as the government committed to its motorway programme, and the old A-road trunk routes gave way to visions of a new kind of freight transport. Faster, heavier, further. The nationalised bus companies modernised their fleets on an enormous scale, replacing pre-war rolling stock with new chassis and new bodies and, wherever the operators could get them, new Gardner engines. The fishing fleets rebuilt to pre-war strength and beyond. The Admiralty, having seen what a Gardner could do in a submarine, continued to specify Patricroft diesels for pinnaces, tenders and auxiliary vessels. Orders stacked up at Barton Hall faster than the works could fill them. The waiting list, which had always been part of Gardner's commercial life, began to grow, and grow, and grow. ERF customers waited months, then a year, then longer. Foden customers waited. Atkinson customers waited. Nobody complained, not yet, because waiting for a Gardner was understood to be part of owning a Gardner. It was the price of perfection. But the waiting list was not a sign of health. It was a symptom of something that nobody in the Gardner boardroom was willing to name. A refusal to expand, a refusal to compromise, a refusal to accept that a market could move faster than the men who served it. The LW carried on, supplemented by new and larger LK and HW ranges, with each successive uprating yielding more torque rather than more revolutions. The Gardner philosophy in miniature, always choosing pulling power and longevity over screaming performance. The smaller 4LK, meanwhile, found its way into British Rail Class Era 1 and Class Era 4 diesel shunters, the little locomotives that nudged freight wagons around marshalling yards the length of the country. Gardner iron was now in the buses, the lorries, the fishing boats, the shunters, and the naval tenders. It was becoming, quietly and without fanfare, the invisible engine of post-war Britain. And then, in April 1958, 2 brothers sat down in the drawing office at Patricroft and designed the engine that would become the most admired, most demanded, and most fatally perfect automotive diesel the world had ever seen. Hugh Gardner and John Gardner, grandsons of the founder, engineers of the old school, men who had grown up inside the works and knew every machine in every shop by its temperament, finalised the LX series, a 10.5-litre direct injection inline 6, cast iron block on an aluminium alloy crankcase, and the feature that would define the range and become the firm's mechanical signature, horizontally braced crankshaft main bearings. Where every other manufacturer tied their bearing caps downward to the crankcase alone, Hugh and John Gardner also braced them laterally, cap to cap across the width of the engine, giving the bottom end a structural rigidity that produced, in practical terms, infinite crankshaft life under the intended duty cycle. Nobody else in the British diesel industry braced their bearings that way. Nobody else needed to. Nobody else was building for forever. The first 6LX gave 150 brake horsepower at 1700 revolutions per minute. Peak torque arrived at barely 1,000 revs, so low you could feel the engine pulling before you heard it working. An 8-cylinder 8LX was conceived for marine and stationary use. Horizontal variants, the 68LX, appeared for underfloor bus installation, the engine that would power the National Bus Company's massive Bristol VR double-decker fleet for the next 2 decades. The 6LX was the beginning. What followed, the 6LXB of 1966, would be the summit, and the summit, as it turned out, would also be the cliff. Chapter 5. The Cathedral of Cutting Oil. In 1966, the 6LX was uprated to the 6LXB, and if any single engine can be said to have represented the pinnacle of British diesel design, this was it. 180 brake horsepower at 1,850 revolutions per minute, 562 pound-feet of torque at 1,000 revs, peak pulling power, arriving at an engine speed so low that the driver barely heard the engine note change. Bore and stroke gave a swept volume of 10.5 litres. Compression ratio was a conservative 15:1. Not high by diesel standards, even of the period, but matched to long-life durability rather than peak output. Independent dynamometer tests recorded a specific fuel consumption of 0.330 pounds per brake horsepower per hour and a thermal efficiency of 39.73%, rising above 40%, slightly below peak torque. No production automotive diesel anywhere in the world matched those figures in 1966. No production diesel would match them for decades. Gardner printed the numbers in their catalogue and challenged anyone in the trade to refute them. Nobody did. The construction details explain why. A one-piece cast-iron dry-lined cylinder block with detachable cast-iron heads ranged in 2 banks of 3, so a single head could be removed without disturbing the others. A serviceability feature almost unique in heavy vehicle diesels. An aluminium alloy crankcase for the automotive version that saved substantial weight over equivalently sized engines from Cummins or Leyland. Those horizontally braced main bearings, the Gardner signature, tying the caps laterally as well as vertically, giving the bottom end a structural integrity that produced effectively infinite crankshaft life under the intended duty. Trunnion-mounted cambox and governor assembly holding 2 tandem-mounted 3-element CAV BPF fuel injection pumps, manufactured in-house, closed-circuit freshwater cooling with centrifugal pump, and a coolant transfer arrangement from block to heads via synthetic rubber joint rings independent of the main gas joint, which was solid steel, virtually eliminating the head gasket failures that plagued contemporary Leyland 680 and Cummins NHC engines. Every feature served durability. Every choice favoured the long life over the quick fix. The 6LXB was not designed to impress. It was designed to outlast everything around it. To understand what made the 6LXB special, what earned it the reputation that truck drivers, bus operators and trawlermen built their businesses around, you had to see one being built. And to see one being built, you had to walk through the gates of Barton Hall Engine Works at Patricroft. Visitors who came to the works in the 1960s and 1970s, and there were many, because Gardner was proud enough to show off its methods and confident enough to believe nobody could replicate them, entered through the main gate off Liverpool Road into a site that covered 7.5 acres of buildings strung along the Bridgewater Canal. The first thing that hit you was the smell. Not one smell, but a layering of them. The heavy mineral tang of cutting oil from the machine shops, the sharp, acrid note of hot iron from the foundry where cylinder blocks were being cast, the sweet chemical edge of paraffin from the parts washing bays, and underneath it all, threading through every corridor and stairwell, the slightly sharper note of high cetane diesel exhaust drifting from the test bays at the far end of the site. These smells didn't fight each other. They blended into a single, unmistakable industrial perfume that anyone who worked there carried home on their overalls every night and could recall decades later in complete sensory detail. The foundry was the beginning of everything. Raw iron and scrap went in. Cylinder blocks, heads and crankcase shells came out, each one cast in moulds made from patterns that Gardner's own pattern shop had carved from hardwood and maintained for decades. The heat in the foundry was ferocious. Open crucibles of molten iron at over 1400 degrees, the air shimmering above the pour, the ground vibrating beneath your feet as the cupola furnace roared. A visitor standing at the foundry door felt the temperature change like walking into another country. The men who worked the pour had forearms like cable and a particular squint from years of staring into brightness that no goggles fully shielded. When a cylinder block came out of the mould and the sand was knocked away, the raw casting had a rough, granular beauty, the shape of the finished engine already visible inside the excess metal, waiting for the machine shops to set it free. The machine shops ran the length of the main building. Rows of lathes, milling machines and grinding stations where crankshafts were turned. Cylinder bores were honed and connecting rods were balanced. The crankshaft work was slow and meticulous. Each crank was roughed from a forging, then turned, ground and polished to tolerances that the average motorcar engine of the period would have found absurdly extravagant. The horizontally braced main-bearing saddles, that structural signature that gave every LX its near-immortal bottom end, were machined in a dedicated section where the relationship between bearing cap, crankcase and lateral brace had to be held to a precision that could not be recovered if it was lost. Get it wrong, and the bearing would fail in 50,000 miles. Get it right, and the bearing would run for 1,000,000. The fuel injection equipment occupied its own department, a section of the works that represented something almost unique in British diesel engineering. Gardner manufactured its own injection pumps, tandem-mounted, 3-element CAV BPF units, built in-house on dedicated machinery that the firm had developed and maintained itself. The injection pump is the heartbeat of a diesel engine. It determines when fuel enters the combustion chamber, how much enters, and in what spray pattern. The difference between a well-calibrated pump and a poorly calibrated one is the difference between an engine that purrs and an engine that clatters. Most diesel engine manufacturers bought their pumps from specialist suppliers: CAV, Bosch, Sims. Gardner bought the basic pump design from CAV and then manufactured the finished assemblies itself, calibrating each one on its own test rigs to tolerances that no outside supplier could have guaranteed to hold across thousands of units. It was vertical integration taken to an extreme that the rest of the industry considered economically irrational. Gardner considered it the only way to build an engine properly. The assembly floor was where the argument about Gardner's methods was sharpest. Joe McCool of Tangent Engineering in Northern Ireland, a specialist with decades of Gardner experience, a man who grew up in the rural countryside watching Gardner's work in Smith's cranes, in draglines, and in Foden and ERF lorries, states that each engine was assembled by one worker, a single skilled fitter taking pride in his individual unit from bare crankcase to finished engine. Eric Ward, who started his apprenticeship at Barton Hall in 1975 and works on Gardners to this day for Walsh Engineering, contradicts this directly. In his recollection, builds were always departmental. One section installed the crankshaft, another fitted the connecting rods and oil feed pipes, another handled the cylinder block and heads. The probable truth is that for the low-volume marine engines, where perhaps 20 units might be ordered in a batch over 12 months, a single skilled fitter could take an engine through from start to finish. But for the volume LW and LX bus and truck production, the assembly was broken into specialist stations, each one slow and deliberate and meticulous, compared with anything that Cummins or Perkins were running on more conventional production lines. Either way, the throughput was perpetually a fraction of the demand. McCool captures the commercial reality in a single sentence. Approached for 20 engines, say, Gardners might reply, "Sure, no problem. Come back in 12 months, and we'll have them ready." Customers in the modern age just could not tolerate such timescales. They couldn't, but they waited anyway, because the alternative was not a Gardner. Every completed engine was wheeled to the number 10 test shop, the beating heart of the works, the room where the product met its standard. Here, each finished unit was mounted on a Heenan and Froude dynamometer and run in under increasing load for several hours. The fuel pump settings were calibrated. The governor was adjusted. The cooling system was tested across the full operating range. Rejection rates were low because the upstream processes were tight. Every component subject to wear had already been gauged, every assembled subassembly already inspected. But the test shop was not a formality. It was the final exam, and Gardner's reputation left the works with every engine that passed it. When a 6LXB passed its test shop run, it was painted, polished, and crated for dispatch, and this is where the aesthetic pride showed itself most nakedly. Gardner crankcases, rocker covers, and ancillaries were polished to a near-mirror finish before leaving the works. The engineering rationale was sound. Polished aluminium is easier to inspect for oil leaks, and the bright surface radiates heat more efficiently than a rough one. But the rationale was only part of the story. The truth was that Gardner's men polished their engines because they believed an engine that looked like a piece of precision craftsmanship would be treated like one. A finished 6LXB, sitting on the railway wagon at the Patricroft goods siding ready for collection, looked closer to a Royal Naval boiler room exhibit than to a piece of commercial vehicle equipment. It gleamed. It was, in its way, beautiful, and the men who'd built it knew it. Chapter 6. 14 Shillings and the Patricroft Streets. The beauty of the product was not matched by the generosity of the wages. Trade union presence at Patricroft was strong through the post-war decades. The Amalgamated Engineering Union for the skilled craftsmen, the Transport and General Workers Union for the semi-skilled assembly and packing operatives, the Association of Engineering and Shipbuilding Draftsmen for the drawing office. The works was not a militant shop floor by the standards of, say, Trafford Park's Metropolitan Vickers or the British Leyland plants at Longbridge and Cowley. Its skilled craftsmen identified more with the engineering content of their work, with the precision, the tolerances, the pride of making something properly, than with the union confederations that represented them nationally. But Barton Hall was unambiguously unionised, and the men who clocked in every morning knew, to the penny, what the equivalent skill grade rates were at other Manchester engineering employers. Gardner paid less, consistently, stubbornly, and across the board. The firm's position was that the quality of the work was its own reward, that a Gardner apprenticeship was the finest technical education in the north of England, and that the satisfaction of building the best diesel engine in the world ought to compensate for the gap between the Patricroft wage packet and the one you could pick up at GEC or Metropolitan Vickers. The workforce was not persuaded. Local memory, preserved in the Socialist Worker account of the 1980 occupation, recorded that Salford schoolteachers used the works as a threat to idle pupils. If you don't buck up, you'll end up at Gardner's. For a firm whose products were routinely called the Rolls-Royce of diesels, that was a striking commentary on the distance between brand prestige and the lives of the people who made the brand possible. In 1973, that distance snapped. A 13-week occupation of the works over pay transformed industrial relations at Patricroft in ways that nobody in the boardroom had anticipated. Collections for solidarity disputes became factory tradition. Socialist politics moved onto the shop floor. Tommy McAfee was elected union convener, a left-wing organiser with a sharp tongue and a genuine talent for mobilisation. Mick Brightman, a member of the Socialist Workers' Party, became senior shop steward. Kevin Cohen ran one of the more militant sections. Stewards leafleted the workforce for the Anti-Nazi League and the Rock Against Racism Carnival in April 1978. The politicisation of the Patricroft shop floor was not an accident. It was the direct consequence of a management that believed its own reputation excused its obligation to pay a fair wage. But the community that the works had built was real, and it ran deeper than the arguments about pay. Multi-generational employment was the norm, not the exception. The terraced streets around Patricroft and Eccles, Liverpool Road, the side streets off the A57, the rows of red brick 2-up 2-downs that ran down to the canal and up toward the railway, fed the works the way tributaries feed a river. A boy who left school at 15 in Patricroft in 1950 had a clear path ahead of him. Through the Barton Hall gates, into the apprentice school, 5 to 7 years of learning to turn a crankshaft and read a micrometer and feel the difference between a bearing that was right and a bearing that was 1/1000th of an inch too tight. Then a lifetime on the shop floor alongside his father and his uncle and, in time, his own son. The family names recurred across the payroll decade after decade. The Gardner workforce was not a labour market. It was a village. The apprenticeship system was the foundation of everything. A Gardner apprentice in the 1950s or 1960s started at the bottom, sweeping floors, fetching tools, watching, and was rotated through every department of the works over the following years. Foundry, machine shop, assembly, injection pump calibration, test shop. By the time a lad came out the other end, he could strip and rebuild a 6LXB blindfolded, diagnose a fuel pump fault by ear, and argue the finer points of bearing clearance with a university-trained engineer and win. Eric Ward, who arrived as an apprentice in 1975, one of the last generation to receive the full Barton Hall training, carries that education with him to this day at Walsh Engineering. It was the kind of formation that no technical college could replicate, because it was learned not from textbooks, but from men who had been doing the work for 30 years, and who would accept nothing from an apprentice that they would not accept from themselves. The works hooter marked the rhythm of the surrounding streets, the morning shift, the afternoon shift, the night shift, and the pubs filled in sequence as the gates opened. The social life was tightly integrated with the works. Gardner had no formal workers' club in the grand tradition of the Northern Colliery welfare halls, but the pubs around Patricroft Station and along Liverpool Road served the same function. The Lamb, the Stanley Arms, the other locals where a man could drink a pint of Boddingtons and argue about the afternoon's work with colleagues who'd been doing the same job for 20 years. The cricket club fielded a works team. The annual Christmas do was a Patricroft institution. And the apprentices, those boys who'd come in at 14 or 15, knowing nothing, and emerged years later as some of the most skilled diesel fitters in England, carried a bond with each other and with the works that persisted long after the gates had closed for the last time. Women worked at Gardner, though the surviving record is thinner than it should be. The wartime years had brought women onto the shop floor in roles that had been exclusively male, and some of those roles persisted into peacetime. The packing department, the stores, the office, the canteen. These were the standard channels, mirroring the wider patterns of British industrial employment in the 1950s and 1960s. But the photographs of the 1980 occupation, taken by John Sturrock, show women workers participating alongside the men on the picket line and inside the occupied works, and the oral record confirms that the workforce was never entirely male, even if the foundry and the machine shops overwhelmingly were. What the wages bought when they arrived in the Friday packet was modest, but solid. A terraced house in Patricroft or Eccles, 2 up, 2 down, a yard out the back, a coal shed, a family car eventually, an Austin or a Morris, nothing flash, nothing that would draw a comment from the neighbours. A week at Blackpool in the summer, or a caravan at Prestatyn if you'd had a good year. A television, a 3-piece suite, a garden shed, shoes for the children at the start of term. It was not wealth, it was stability. And stability, in the working-class culture of post-war Lancashire, was not a small thing. It was the architecture of a life built on the certainty that the work would always be there, that the gates would always be open on Monday morning, that the hooter would always sound. That certainty was the invisible product of Barton Hall, more valuable, in the end, than any engine. More valuable and more fragile. Because it rested on an assumption that nobody in the Patricroft streets ever thought to question, that a product so well made would always find a buyer. That quality, in and of itself, was a guarantee of survival. The engines survived. They ran for decades. They are running still, on narrowboats and in generator sheds, and in the engine rooms of trawlers that have outlived the fleet they were built for. But the certainty that built those terraced street lives, the certainty that the wages would always come and the gates would always open, that was destroyed, and nothing that has come since has replaced it. Chapter 7. The Engine That Mourned. Churchill, by the mid-1960s, the scale of Gardner's quiet dominance was extraordinary. Up to the mid-1980s, Gardner engines powered roughly 90% of British-built buses. Not a majority, not a plurality, 90%. Every national bus company fleet, every municipal operator from Aberdeen to Plymouth, every Bristol VR double-decker that carried schoolchildren and shoppers and pensioners across the length of England, Wales and Scotland. Almost all of them ran on Patricroft iron. The 6HLXB, the horizontal variant of the LXB designed for underfloor installation, was the standard engine of the NBC for 15 years. When Leyland's own disastrous 500 series fixed-head engine proved catastrophically unreliable, cracking cylinder heads, burning valves, consuming oil at rates that made depot managers weep, the National Bus Company went to Patricroft, cap in hand, and specified Gardner for the Leyland National. The company that had spent decades refusing to fit someone else's engine into its own chassis was forced to admit that someone else's engine was the only one that worked. The phrase, Gardner or nothing, was not a marketing slogan. It was an operating philosophy, spoken without irony in the boardrooms and workshops of British road haulage. Gardner-engined ERF, Foden and Atkinson 8-wheelers and 32-ton Arctics from the 1960s and 1970s routinely ran 1 million miles between major rebuilds. 1 million miles. That is not a typographical error, and it is not an enthusiast's exaggeration. It is a documented performance record, repeated across hundreds of vehicles, confirmed by operators who kept meticulous fuel consumption and maintenance logs because their livelihood depended on it. Smith of Maddiston, BRS Parcels, Norman Lockett, Stiller, James Earlham, McKelveys of Glasgow. These were not sentimental men. They were hauliers, and they ran Gardners because Gardners made them money. More miles between rebuilds, fewer breakdowns on the A1, better fuel returns per gallon than anything Cummins or Leyland could offer. Second-hand values held against time. A used Gardner-engined lorry was worth more than a newer lorry with a competitor's engine, because the buyer knew what the Gardner would do and for how long it would do it. Operators trusted Gardner power the way they trusted gravity. It was not a choice. It was a fact of the commercial universe. The marine figures told the same story from a different angle. By the 1960s, an estimated 83% of new British-built fishing vessels were Gardner-powered. About 45% of total Gardner output went to fishing boats, and 59% of those were exported. The fish and chips that fed a nation came home in trawlers that ran on Patricroft diesels, out of Fleetwood, Hull, Grimsby, Aberdeen, Newlyn, harbours the length of Britain's coastline. The deep, slow, rhythmic thump of a Gardner marine engine at cruising speed was the heartbeat of the British inshore fishing fleet, and any fisherman who'd spent a winter night on the North Sea with a Gardner beneath his feet knew what reliability meant in a way that no trade press road test could convey. The bigger Gardners, the 6L3 and 8L3, derived from the LX, powered British Rail Class Euro 1 and Class Euro 4 diesel shunters, the little locomotives that nudged freight wagons around marshalling yards from Crewe to Carlisle. They powered the maxi yachts, Condor and Condor of Bermuda. They powered Smith's mobile cranes on construction sites across the country. The engine was everywhere, doing everything, and almost nobody outside the trade knew its name. And then there were the showmen. From at least the 1950s, the travelling fare generator engine of choice was a Gardner, most often a 5LW, a 6LW, or, in the LX era, a 6LXB driving a Stamford alternator. The deep, syncopated chug of a Gardner generator at a fairground, one combustion event every other revolution per cylinder, turning at 1,500 revolutions per minute, the exhaust notes slow and methodical and utterly unlike the frantic rattle of a modern high-speed diesel, is, for anyone who grew up in Britain between 1955 and 1985, the soundtrack of childhood. The smell of hot diesel mixed with candy floss and fried onions, the vibration in the ground near the generator truck, the sound carrying across a field on a summer evening, pulling you toward the lights before you could see them. In 2026, hundreds of show generators across the British Isles still run on Gardners, because the showmen trust them, because the engines were built to a standard that makes replacement unnecessary, and because the sound itself has become part of the tradition. Mike Humble of Auto Britannia captured it. Fill my ears and nose with the sound and smell of a showman's generator engine. That was not an engineering assessment. It was nostalgia for something that is still alive. And there was the bus. The Gardner-engined Bristol VR double-decker is the single most universally familiar Gardner-powered object in Britain. Operated by Crosville across North Wales and Cheshire, by Bristol Omnibus, by Eastern Counties, by United, by Western National, by Southern Vectis and Hants and Dorset, it was the standard national bus company double-decker from 1970 to deregulation in 1986, and some were still on routes as late as 2000. For anyone who took a school bus, a holiday charabanc, or a town service outside London in the 1970s and 1980s, the 6HLXB's note is the sound of a British bus, that unmistakable slow chug at idle, the unhurried climb of revs that never seemed in a hurry, the absence of the chattering rattle that betrayed a Leyland or a Cummins. Preserved examples are still toured to rallies. Enthusiasts record their idling note and post the recordings online, where they attract audiences that would surprise anyone who thinks diesel engines are merely functional objects. The most famous Gardner-powered vessel never carried fish or pulled a fairground ride. MV Havengore was a Port of London Authority Nor launch, 65 feet of varnished teak and brass, powered by twin Gardner 8L3 engines. On the 30th of January 1965, she carried the coffin of Sir Winston Churchill down the Thames from Tower Pier to Festival Pier as part of the state funeral. The last state funeral given to a commoner, broadcast live to a global audience of hundreds of millions. The cranes of the Pool of London dipped their jibs in salute as Havengore passed. The country mourned its greatest war leader to the sound of a Patricroft engine. It is melodramatic to say so, but it is also factually accurate, and nobody at Barton Hall that day needed to be told. Chapter 8. The View from the Summit. By 1970, the 8LXB had joined the range. 13 9/10 litres, 240 brake horsepower at 1,850 revolutions per minute, 728 pound-feet of torque at 1,000 revs. The trade press called it the smoothest running automotive diesel ever built, and the men who drove it agreed. The horizontal 6ALXB at 180 horsepower was the standard bus engine of the National Bus Company. The smaller naturally aspirated 6LX had been uprated in 1967 to the 6LXB specification. The mid-1960s had seen the old LW range itself uprated to 20 horsepower per cylinder and rebranded as the LW20. Each step was a worked refinement of a known design. Nothing was clean sheet. Nothing was radical. Everything was a shade more polished, a fraction more efficient, a degree more perfect than the version before. And that, precisely, was the problem. The M1 motorway had opened in 1959. The M6 was pushing north. The M62 would soon connect Liverpool to Hull across the Pennine Spine. Britain's heavy haulage industry was changing its shape. Longer distances, higher speeds, heavier loads. The construction and use regulations that governed lorry weights had been ratcheting upward. 24 tons gross vehicle weight in 1964, 32 tons gross combined weight for articulated vehicles in 1972, with a statutory minimum of 6 brake horsepower per ton introduced after 1973 to ensure that heavy vehicles could maintain adequate speed on motorway gradients. A 32-tonner needed 192 horsepower. A 38-tonner, the weight that was coming, that everyone in the industry knew was coming, would need 228. The 6LXB at 180 could just legalize a 32-tonner. Just. If the operator was willing to accept that his vehicle would labor up Shap Fell or Beatwick Summit at a pace that held up traffic and burned fuel in quantities that negated the Gardner's legendary economy. The 8LXB at 240 could handle a 32-tonner comfortably, but it was heavy, expensive, and produced in small numbers. Nothing in the Patricroft range could plausibly haul a 38-tonner at motorway speed. Meanwhile, the Swedes had arrived. Volvo's F88, carrying a turbocharged 9.5-litre engine, producing 260 brake horsepower, had landed in Britain in 1967. It brought with it a fully sprung tilt cab with sleeping accommodation behind the seats, power steering, an exhaust brake, and an integrated approach to driver comfort and serviceability that no British manufacturer had ever offered or even attempted. Scania's 110 series followed close behind, with a turbocharged 11-litre engine and cold-starting reliability that gave it dominance in the Scottish Highlands fleets within a decade. DAF arrived from the Netherlands. Mercedes-Benz arrived from Stuttgart. The Cummins NTC 290, built in Scotland at the new Shotts plant, walked past anything Gardner offered, as though the Patricroft engineers were standing still. The trade press noticed. Commercial motor road tests routinely placed the Volvo F88 and Scania 111 first and second in long-distance trunking categories by the mid-1970s. Gardner-engined British competitors were trailing. The numbers were not a matter of opinion. They were published. They were read by every fleet manager in the country. And at Barton Hall, in the drawing office, where Hugh and John Gardner had created the 6LX 17 years earlier, the response was silence. The waiting list by now had stretched to 2 years. ERF customers, Foden customers, Atkinson customers, they waited 24 months for a Gardner-engined chassis, while Volvo offered immediate delivery of a more powerful truck, with a better cab and a warranty to match. The waiting list, which had once been a badge of honour, proof that the product was worth having, had become something else entirely. It had become the most visible symptom of a firm that believed its own legend so completely that it could not see the market moving away beneath its feet. The customers were starting to hedge. ERF had introduced its first Cummins-powered chassis as far back as September 1961, an 8-wheeler for C. Butt of Northampton, and had added Rolls-Royce Eagle as an option in 1958. Gardner was still first choice, but it was no longer the only choice. Foden had built its own 2-stroke FD6 diesel from 1948 alongside Gardner's, and from 1970, the Cummins NHC was a standard option in the Foden range. Atkinson, merged into Seddon Atkinson in 1970, had shifted to Rolls-Royce Eagle and Cummins for heavy haulage. The web of dependency that had sustained Patricroft for 40 years was fraying, thread by thread, and the man at the centre of the web could not see it happening because he was looking at a dynamometer reading instead of looking out of the window. Hugh Gardner sat in the chairman's office at Barton Hall. He was 70 years old. He had started in the number 10 test shop at 14 shillings a week. He had designed, with his brother John, the most thermally efficient diesel engine in the world. He had spent his entire life inside these walls, and every lesson that life had taught him pointed in the same direction. Build slowly, build perfectly, and the world will come to you. It always had. It always would. The waiting list proved it. He was wrong, and the next decade would prove it in ways that would destroy the company, the community, and the engineering tradition that his grandfather had started in a Hume cellar 100 years before. Chapter 9. The Motorway and the Swede. The M1 motorway opened in 1959. From that moment, the British heavy haulage market was on a trajectory that Gardner could not follow, and as it turned out, would not try. The arithmetic was simple and brutal. The construction and use regulations governing lorry weights had been ratcheting upward through the post-war decades. 24 tons gross vehicle weight in 1964, 32 tons gross combined weight for articulated vehicles in 1972, and the 38-ton ceiling that everyone in the industry knew was coming, and that would arrive in 1983. After 1973, a statutory minimum of 6 brake horsepower per ton was imposed to ensure that heavy vehicles could maintain adequate speed on motorway gradients without blocking the inside lane at 30 miles per hour on every incline between London and Glasgow. The regulation was practical and overdue. Anyone who had been stuck behind a grossly underpowered Arctic grinding up the A6 over Shap in low gear understood why the rule was needed. The consequences for Patricroft were existential. A 32-tonner at 6 horsepower per ton needed 192 brake horsepower. The 6LXB at 180 could just legalise a 32-tonner, technically, on paper, by the narrowest of margins. But just legalise and haul competently up Shap Fell at motorway speed on a wet Thursday in January with a full load and a headwind were two entirely different things. The 6LXB would labour. It would hold up traffic. It would burn fuel in quantities that negated the legendary Gardner economy that was supposed to be its commercial justification. The 8LXB at 240 could handle a 32-tonner comfortably, but it was heavy, expensive, and produced in such small numbers that ordering one felt more like commissioning a bespoke suit than buying a truck engine. And a 38-tonner? Nothing in the entire Patricroft catalogue could plausibly haul a 38-tonner at motorway speed. Nothing. The most powerful naturally aspirated engine Gardner made, the 8LXB, produced 240 horsepower from nearly 14 litres. A 38-tonner at the 6 horsepower per tonne rule needed 228 minimum, leaving almost no margin for gradient, headwind, or the simple reality that gross vehicle weight ratings were optimistic. Meanwhile, the Volvo F88 produced 260 from 9.5 turbocharged litres. The Scania 140 produced 350. The Cummins NTC 290 produced, as its name suggested, 290. These engines were not merely adequate for the new weight limits. They were designed for them. The Patricroft engines were designed for a Britain that no longer existed, a Britain of A-roads and 24-ton Arctics crawling behind combine harvesters on single-carriageway trunk routes. Cummins was the most dangerous competitor because Cummins was already inside the house. The American firm had opened its Shotts plant in Scotland in the 1960s, manufacturing and rebuilding engines within the UK rather than importing them. Daventry and Darlington followed. Cummins understood the British market because Cummins was in the British market, employing British workers, building engines on British soil, offering British hauliers a dealer network, a warranty structure, and a parts supply chain that Gardner had never bothered to match. By the time Gardner accepted that capacity was a problem, Cummins had walked into the gap that the 2-year waiting list had created and made itself the de facto British heavy truck engine. The gap had not been forced open by foreign aggression. It had been left open, patiently and deliberately, by a firm that believed its customers would wait forever. They wouldn't. They hadn't. 2 of the new European entrants deserve specific attention because they didn't just compete with Gardner, they redefined what premium meant in the British long-distance haulage market. Volvo's F88 was as significant in British transport terms as the arrival of the Boeing 747 had been in British aviation. It was not merely a truck with a more powerful engine. It was a complete rethinking of what a lorry driver's working life should look like. a fully sprung tilt cab with sleeping accommodation behind the seats, power steering, an exhaust brake, a twin-stage clutch, a turbocharged 9.5-litre engine that produced 260 horsepower without stress, and an integrated approach to driver comfort and serviceability that no British manufacturer had ever attempted, because British manufacturers built chassis and bought in engines and cabs from separate suppliers, and nobody was responsible for the whole vehicle as a living, working environment. Volvo was responsible. Volvo designed the cab around the driver. Volvo designed the engine around the cab. The F-88 arrived in Britain in 1967 and within a decade had captured the prestige long-distance fleets that Gardner had assumed were permanently loyal. Scania's 110 and 140 series delivered similar virtues, plus a reputation for cold-starting reliability that gave them dominance in the Scottish Highlands fleets, the most demanding operating environment in Britain, where temperatures fell below -15, where gradients could break a gearbox, and where a breakdown 50 miles from the nearest dealer meant a driver sleeping in his cab until the recovery truck found him. Scottish hauliers had been Gardner loyalists for decades. Scania took them away. Inside the Barton Hall drawing office, the engineers could see what was happening. Steve Field, who joined the R&D and Applications Engineering Department in 1976 under Gordon Parker, was part of a generation that understood the competitive landscape in precise technical detail. They knew the LXB was being outdeveloped. They knew the power-to-weight ratios were wrong. They knew that the European manufacturers were building not just more powerful engines, but better integrated vehicles. Trucks, where the engine, the gearbox, the cab, the suspension, and the driver's environment were designed as a single system, rather than assembled from a catalogue of independent suppliers. The British model, buy a chassis from ERF or Foden, specify a Gardner engine, add a David Brown gearbox and a Kirkstall axle, was being superseded by manufacturers who took responsibility for everything and guaranteed the result. The engineers knew this. The boardroom did not want to hear it. The waiting list was both the proof of the problem and the excuse for ignoring it. At its worst, through the late 1960s and into the 1970s, ERF, Foden and Atkinson customers were quoted 2-year delivery times for a Gardner-engined chassis. 2 years. A haulier who needed a new vehicle to fulfill a contract starting in January 1971 had to have ordered it in January 1969. Gardner could have built a second factory. They could have licensed production to another British engine maker. The AR Online Trade Forum speculates that a deal with Meadows of Wolverhampton would have rescued applications at Guy, Bedford, Dennis and Ford. They could have double-shifted Barton Hall. They did none of these things. The waiting list was, to the Gardner boardroom, not a commercial failure, but a confirmation of excellence. People were waiting because the product was worth waiting for. The possibility that they might stop waiting, that they might, one by one, discover that a Cummins NTC 290 delivered 90% of the durability at twice the power and immediate availability, was a thought the boardroom refused to entertain. Michael Harrison, who now runs Gardner Marine Diesels in Canterbury and holds much of the original Barton Hall tooling and drawing archive, describes the philosophy plainly. The Gardner family from the beginning, and Hugh Gardner in particular, was obsessed with wringing the maximum thermal efficiency out of the engines he designed. Obsessed is a word that carries two meanings. It can mean passionately devoted to excellence, or it can mean unable to see anything else. In Hugh Gardner's case, both meanings applied simultaneously, and the second one destroyed the firm. There was one obvious technical solution, and every competitor had already adopted it. A turbocharger. Hugh Gardner would not permit it. Chapter 10. The turbocharger in the corner. Hugh Gardner's objection to turbocharging was not stupid. It has been too easy, in the decades since, to dismiss him as a stubborn old man who couldn't keep up with the times. The truth is harder and more interesting, and understanding it is essential to understanding how a man of genuine intelligence and deep engineering knowledge could make a decision that destroyed the firm he loved. A turbocharger adds thermal and mechanical stress to every combustion event. It raises peak cylinder pressure by as much as 50%. It increases exhaust gas temperature to levels that demand improved metallurgy in the valves, the guides, the exhaust manifold. It requires an intercooler to bring the compressed intake air back down to a temperature the engine can tolerate. an oil feed circuit to lubricate the turbo bearings, a wastegate to control boost pressure, and a control system that adds layer upon layer of complexity to an engine whose entire design philosophy was the systematic elimination of complexity. Hugh believed, and he was not entirely wrong, that turbocharging compromised the very thing that made a Gardner: slow, smooth, naturally aspirated, long-stroke combustion, producing maximum thermal efficiency at minimum mechanical stress, running at revolutions per minute that other manufacturers wouldn't tolerate because they couldn't sell the low headline horsepower that resulted. A Gardner engine ran at 1,850 revolutions per minute when Cummins was chasing 2,200 and Volvo was pushing higher still. It produced its torque low and held it flat across the operating range. It did not scream. It did not overstress. It did not break. And Hugh Gardner, who had started in the number 10 test shop in 1921 at 14 shillings a week and had spent more than half a century learning what made these engines outlast everything around them, was not willing to throw that away for a few extra horsepower that he believed the customer would abuse and the engine would resent. He had seen engines come and go. He had seen competitors chase power and lose durability. He had watched Leyland's 500 series destroy the reputation of Britain's largest vehicle manufacturer through exactly the kind of rushed, power-hungry development that turbocharging represented to him. He would not make the same mistake. He was right about the engineering principle. He was catastrophically wrong about the market. The market was not asking for his opinion. The market was asking for 290 horsepower, and if Patricroft wouldn't provide it, Schatz and Gothenburg and Södertälje would. The most quoted episode in the Gardner story, the moment the firm's future was killed, involves Hugh's nephew, Paul Gardner. Paul was a younger generation, an engineer who had grown up with the same precision culture, but who possessed something Hugh lacked, the ability to look outward at what the competitors were doing, at what the customers were demanding, and to understand that the market's definition of excellence had shifted beneath Gardner's feet. Sometime in the late 1960s or early 1970s, the exact date is disputed because the event was never officially recorded in any company minute, Paul quietly built and tested a turbocharged prototype engine in the experimental section of the works. He did it in secret because he knew what Hugh's reaction would be. He ran the engine on the dynamometer. It worked. The power figures were there. The thermal efficiency, while slightly lower than the naturally aspirated units, as Hugh would have predicted, was well within acceptable bounds. Paul had the evidence. He took the results to his uncle. Hugh Gardner gave Paul an ultimatum. Stop the turbocharger program, or I resign from the chairmanship. Paul stopped. There is no public record of what passed between them in that conversation, whether it was an argument or a cold instruction, whether Paul fought his corner or folded immediately, whether anyone else in the boardroom was present, or whether it happened in Hugh's office with the door shut and the dynamometer charts spread across the desk. What is recorded by Mike Humble of Auto Britannia and in the recollections of former employees on the AR Online forums is the outcome. The turbocharger was shelved. The prototype was put aside. The most urgent technical development in the firm's history was killed by a single conversation between an uncle and a nephew, and the nephew chose family loyalty over the commercial survival of the enterprise that 4 generations of his family had built. It was not the only opportunity Paul tried to create. Around the time of the Rolls-Royce bankruptcy in 1971, when the aero engine division collapsed and the government nationalised what it needed and let the rest fall, Paul suggested that Gardner buy the Rolls-Royce diesel plant at Shrewsbury. The acquisition would have given Patricroft access to Ministry of Defence contracts, a larger engine portfolio, and a manufacturing base that could absorb the volume the Barton Hall site could not handle. It was a strategic vision that might have transformed Gardner from a craft-scale producer into a medium-volume manufacturer with the military-industrial connections to survive the civilian downturn. Hugh killed that too. The Shrewsbury plant was eventually bought by Perkins, the same Perkins that would, 15 years later, acquire Gardner itself and dismantle it. The consequences rippled outward through the customer base, and the ripples became waves. John Killingbeck, a private operator running an Atkinson Borderer, was forced by the 1973 6 horsepower per ton rule to stretch his chassis into a Chinese 6x2 configuration with an uprated 6LXB, renaming the vehicle the Buccaneer. It was an act of mechanical ingenuity driven by regulatory desperation, the kind of improvisation that loyal customers had to perform because Gardner would not build the engine they actually needed. Killingbeck's Buccaneer is preserved today, a monument to what happens when a manufacturer's philosophy collides with a customer's reality and the customer is left to fix the problem himself. Atkinson itself had already begun shifting away. The Ministry of Transport's fleet of 6x6 motorway gritters, built by Atkinson between 1962 and 1973, carried Cummins NHK engines, not Gardner's, partly because the alloy crankcase Gardner's suffered salt corrosion in the gritting application, a durability failure in exactly the kind of hostile environment where Gardner engines were supposed to be invincible, and partly because Cummins could deliver the engines when Gardner could not. By the late 1970s, the Atkinson Defender and Borderer Rangers offered Gardner only as a traditionalist's option, the choice of the owner-driver who loved the mark, not the fleet manager who needed a truck by Tuesday. ERF, the firm that had been born around the Gardner engine in 1933, was buying Cummins in growing numbers. The B-Series ERF of the mid-1970s was routinely specified with the Cummins NTE 290 by fleet operators who could not afford to wait 2 years for a chassis when there were loads to move this week. Gardner's purchase of 8.5% of ERF's equity in April 1977, an investment of company money in a customer's shares, designed to preserve the relationship through financial entanglement, was a measure of how desperate and how confused the commercial position had become. You do not buy shares in your own customer to keep them loyal. You build the engine they need. Inside the works, the frustration was real but contained. The engineers could see the problem. The shop floor could feel it in the thinning order book. But the family held the boardroom, and the family followed Hugh. It took, as one trade observer on the Air Online forum summarized, a subtle director's coup to move Hugh from the chairmanship into a purely engineering role, opening the door to what came next. But by then, the competitors had passed them by, and the door opened onto a landscape that bore no resemblance to the one Hugh Gardner had spent his life defending. Chapter 11. The Coup That Came Too Late. The corporate maneuvering that led to Gardner's sale was swift, complicated, and, for those who loved the firm, a succession of blows that each arrived before the last one had stopped hurting. In June 1976, Rolls-Royce Motor Holdings acquired around 17% of Gardner's ordinary shares. The trade press read it as a takeover signal. Commercial Motor ran the story under the headline, "Gardner versus Rolls in Takeover Move." Gardner responded by buying 8.5% of ERF in April 1977, a defensive cross-holding designed to make a hostile acquisition more complicated by binding Gardner's fate to its largest customer. The maneuver bought months, not years. In August 1977, the Hawker Siddeley Group completed its acquisition of Gardner by cash offer for the remaining shares. The acquirer was then led by Sir Arnold Hall, a former aeronautics researcher who had become chairman and was steering the group through one of the most disorienting episodes in British industrial history. The 1977 Aircraft and Shipbuilding Industries Act had nationalised Hawker Siddeley Aviation and Hawker Siddeley Dynamics, the beating heart of the company's aerospace business, the divisions that traced their lineage back to Sir Tommy Sopwith and the Camel, into British aerospace. Roughly a quarter of the group's turnover had been removed at a stroke. Hall needed to redeploy the surviving capital into other industries, and engineering subsidiaries, electrical, mechanical, locomotive, marine, were the chosen ground. Gardner fitted the strategy on paper, a respected British engineering brand with strong cash flow, a defensible market position in buses and marine, and the modernisation potential that the Gardner family had refused to fund. A well-capitalised parent could, in theory, build the larger-engined, turbocharged Gardners that the market demanded, while preserving the quality culture that made the brand worth having. The theory was reasonable. The practice was something else. Hugh Gardner retired from the board in 1978. He died in September 1989. Motorsport published the obituary. His brother John also left. Paul Gardner stayed, and Paul, at last, got his turbocharger. The 6LXCT, a turbocharged 6LXC producing around 230 brake horsepower, and the 8LXCT, producing up to 300, entered the Gardner catalogue in the late 1970s and early 1980s. They were technically competent engines, well designed within the Gardner tradition, and they represented everything that Paul Gardner had been fighting for since the day his uncle told him to stop. But they arrived into a market that had already made its choices. The Cummins L10 was in advanced development. The Rolls-Royce Eagle 290 was selling well. The Volvo F10 and F12 were the prestige choices for British long-distance haulage. The Scania 111 and 141 dominated the Scottish and Nordic routes. Commercial motor road tests placed the European contenders first and second in every long-distance category, and the reviews were published, read by every fleet manager in the country, and acted upon. The moment when a turbocharged Gardner could have changed the competitive landscape, the late 1960s, when British hauliers were desperate for more power from the marque they trusted, had passed a full decade ago. The 6LX-CT was the right answer to the right question, delivered to a market that had stopped asking. Hawker Siddeley, meanwhile, discovered what corporate owners of craft tradition firms invariably discover, that the culture that makes the product exceptional is the same culture that resists modernization, and that imposing efficiency on a workforce that defines itself by the refusal to be efficient is a confrontation that generates more heat than light. The expected returns on investment did not materialize. The truck market was contracting under the combined pressure of recession, the 1979 oil shock, and the continuing European invasion. The bus market was shifting, with deregulation now openly discussed in conservative policy circles. And the corporate appetite for spending money on a Manchester diesel engine works that kept fighting redundancies and demanding investment was, to put it diplomatically, limited. The investment that might have saved Gardner, the new production line, the new engine range, the integration with Hawker Siddeley's wider engineering capabilities, never came. And what came instead was the redundancy notice. Chapter 12. 6 weeks on the shop floor. In October 1980, with Britain in deep and worsening recession under the first Thatcher government, Hawker Siddeley announced 590 redundancies from Gardner's 2,500-strong workforce. The response was immediate and disciplined. Tommy McAfee, the union convener who had been building organisational capacity on the Patricroft shop floor since the 1973 pay dispute. 7 years of patient groundwork. 7 years of building the trust and the structures that would be needed when the moment came, called a mass meeting. Mick Brightman, the senior shop steward, mobilised his network. Kevin Cohen and the other stewards worked their sections with the speed and coordination of men who had rehearsed this in their heads for years. The workforce voted overwhelmingly to occupy. Hundreds of workers moved into the factory and refused to leave. They slept beside their lathes and their milling machines. They organised with a thoroughness that put the management to shame. Committees were formed to run the canteen, organise the picket rota, administer the hardship fund, and maintain safety inspections throughout the occupied plant. Delegations were sent to workplaces across the country, 50 in Glasgow alone in 3 days, raising solidarity money with a directness that alarmed the Engineering Employers Federation into issuing warnings to its own member firms about the Gardner delegation's effectiveness. The total Solidarity Fund reached £77,000, roughly $300,000 in 2020 money, raised from fellow workers at factories, foundries and workshops who understood that an injury to one was an injury to all. The AUEW, the Amalgamated Union of Engineering Workers, the successor to the old Amalgamated Engineering Union that had represented Patricroft craftsmen since the war, agreed strike pay and agreed it fast. One delegation, frustrated by bureaucratic delay, had threatened to occupy the union's own London headquarters until the money was released. The money was released. For 6 weeks, the workers held the factory. The occupation became, briefly, a cause célèbre on the industrial left, a demonstration that mass redundancy could be resisted, that workers were not obliged to file quietly out of the gates when a distant boardroom decided their labour was surplus. Photographer John Sturrock documented the occupation in images that remain the best visual record of late-period Patricroft, workers sleeping next to their machines, eating pie and chips on the shop floor, the AUEW banner pinned across the gates, the quiet determination of men and women who knew they were fighting for something that mattered. After 5 weeks, Hawker Siddeley entered negotiations. After 6, the redundancy notices were withdrawn. Every single one of them. Other demands were met. Mick Brightman's summary carried the clarity of a man who had won. Everyone has the right to work, and therefore the right to fight for his or her job. Nobody has the right to vote to send another worker down the road. Among the Thatcher-era industrial occupations, the sit-ins, the work-ins, the last-ditch defences of plants and pits and yards that defined British industrial relations in the early 1980s, the Gardner occupation stands out as a clean victory. One of the very few large workplaces in Thatcher's first term to defeat mass redundancy outright. The smaller Lawrence Scott Motors occupation in nearby Openshaw followed a few months later, partly inspired by the Gardner success. Jeff Brown, writing in Socialist Worker on the 40th anniversary in 2020, framed the significance. At last, there was a real victory in a big company. The lesson was not lost. Many employers now thought twice about redundancies. But the victory was Pyrrhic, and the workers who had slept beside their lathes knew it even as they celebrated. The redundancy notices were withdrawn. The workforce kept its jobs, but the fundamental commercial position of the firm had not improved by a single horsepower. The turbocharged engines were in the catalogue, but the customers had largely gone. The British truck industry was contracting. The bus market was about to be deregulated, and Hawker Siddeley's appetite for further investment in a Manchester diesel engine works that kept occupying itself and demanding solidarity from Glasgow was, to put it mildly, limited. By 1985, Hawker Siddeley was looking for a buyer. In summer 1986, after months of denials in the trade press, Perkins Engines of Peterborough acquired Gardner. Perkins, at that point, owned by Massey Ferguson, the agricultural machinery giant, built lighter, higher-volume diesels. The Phaser, the T6.3 engines for tractors, generators, and light commercial vehicles. They saw two attractions in Gardner: the aftermarket spares revenue from thousands of engines still in service worldwide, and the remnant bus and coach customer base. They had no interest whatsoever in the heavy truck market, which by 1986 had gone entirely to Cummins, Volvo, and Scania. They had not come to Patricroft to build trucks. They had come to harvest. Production was halted from the acquisition until October 1986, while Perkins assessed the books. The truck engine line was quietly wound down. The bus, coach, marine, industrial, and showman markets were milked for remaining revenue, while new investment was minimal. The works that had once designed and manufactured the most thermally efficient diesel in the world was now being run as a cash extraction operation. The inventory sold off, the aftermarket maintained, the brand name kept alive just long enough to squeeze the last value from a customer base that was shrinking by the year. The 6 Loy T of 1986, Gardner's clean-sheet response to the post-Hawker Siddeley expectations for emissions compliance and power density, went into limited production with reliability problems that did the marque no favours. It was meant to be the new beginning, a modern engine that preserved Gardner quality while meeting the performance standards of the 1980s. Instead, it became the symbol of everything that had gone wrong. A design rushed through development gates that the old Gardner would never have permitted, released with faults that the old Gardner quality culture would never have tolerated, and sold at prices that made the competition look generous. One Pacific fishing boat owner, writing years later on a marine forum, captured the sadness in terms that every Gardner enthusiast understood. "I have a 6 LOIT in my fishing boat here in the middle of the Pacific Ocean, and I just pulled it out. Can't afford the parts, so expensive. For a crankshaft with overhaul kits, it costs 23,000 New Zealand dollars, equal to the value of a Cummins 350 horsepower. However, I feel very sorry to see my Gardner leaving." The Transport Act 1985, which deregulated the British bus industry, delivered the secondary blow that Perkins had not anticipated. The standardised national bus company procurement budgets that had kept the 6HLXB selling in bulk for 15 years disappeared overnight as the NBC was broken up and privatised. Operators no longer had the centralised purchasing power to specify Gardner across entire fleets. Second-hand buses flooded the market as new private operators bought up surplus NBC stock at pennies on the pound, killing new-build orders for years. The 1992 Euro I emissions regulations were the final impossibility. Re-engineering the naturally aspirated 6LXB and turbocharged 6LXCT to meet the new particulate and nitrogen oxide limits, with Euro 2 already on the horizon for 1996, would have required a clean-sheet combustion system redesign that Perkins was not prepared to fund for a product line that no longer fed any volume customer. The marine market, meanwhile, was shifting away from low-speed, high-torque designs like the Gardner toward marinized automotive turbo diesels from Volvo Penta, Yanmar and Cummins that delivered higher power to weight at lower cost, even though their service life was a fraction of a Gardner's. The market no longer valued what Gardner valued. The market valued cheapness and power. Gardner valued durability and efficiency. The gap between those two philosophies had become unbridgeable. Automotive engine production at Patricroft ceased in 1994. Marine production limped on for another year or two at desperately low volume. Perkins then sold what was left of Gardner to a Manchester-based entity called the Texas Group. Paul Gardner, the man who had built the turbocharger prototype, who had been told to stop by his uncle, who had finally got his chance under Hawker Siddeley only to watch the market disappear beneath him, ran a remanufacturing operation from a corner of the old Barton Hall plant under the name Paul Gardner Engineering. The full circle was complete. The firm that had started in a cellar finished in a corner. Paul Gardner Engineering folded in the early 2010s. The workforce, which had stood at 2,500 in 1980 when the occupation saved their jobs, fell below 1,000 by the late 1980s and to a few hundred by the end. The redundancies came in stages: natural attrition, compulsory departures, early retirement packages, and never produced the spectacular confrontation of 1980, because by then the workers knew, and the unions knew, that the customer base had gone. There was no political point to be made. This was not Thatcher's wreckage, whatever the left wanted to claim. It was not Perkins's wreckage, whatever the enthusiasts wanted to believe. It was the long, slow, irreversible consequence of a family boardroom's own choices, compounded by two successive corporate owners who used the brand without investing in it, and a market that moved on while Patricroft stood still. The press coverage of the closure was minimal. No front-page headlines, no parliamentary debates, no cameras at the gates. Gardner was, by 1994, simply a name from another era, and its passing did not register at national news level. The works that had powered the buses, the lorries, the trawlers, the submarines, the shunters, and the funeral barge of Winston Churchill fell silent without anyone outside the trade noticing it had stopped. Chapter 13. Hardy Street, Eccles. The Barton Hall site was redeveloped, piecemeal rather than dramatically, into the Barton Hall Industrial Estate, a complex of generic warehouse and light industrial units off Hardy Street and Liverpool Road, Eccles, Salford M30. Half a mile from Junction 11 of the M60, half a mile from Junction 1 of the M602. The units are advertised by commercial agents in the universal language of post-industrial Britain. Drive-in level loading, concrete floor, secure manned estate with 24-hour access. There is no Gardner plaque on the gates. There is no statue. There is no engine on a plinth at Patricroft Station, even though the station sits a few hundred yards away and is itself one of the oldest passenger stations in the world. Some of the original brick frontages on the canal side are partly preserved as facades to modern warehousing. Most of the foundry, the machine shops, and the test bays are gone. The Bridgewater Canal still flows along the southern boundary. The railway still runs along the eastern edge. The transport infrastructure that drew Thomas Harry Gardner to this site in 1899 is all still there. Everything else has been replaced by concrete floors and roller-shuttered doors. What survives of the Gardner engineering tradition is scattered, tenacious, and kept alive by people who refuse to let it die. The Anson Engine Museum at Poynton, Cheshire, about 25 miles southeast of the old works, holds the most extensive collection of historical Gardner engines in the world, at least 20 in permanent display, including the Type 0 of 1895, the Robinson hot air engine that started it all, a sectioned 6LX, a 4LK of the type that went into the midget submarines, and the 350 horsepower 6LYT. Annual rallies bring restored Gardner-powered buses, lorries, narrowboats, and stationary engines together in a field where the sound of a dozen Gardners running simultaneously is, for anyone who remembers, almost unbearably moving. Gardner Marine Diesels Limited, run by Michael Harrison from a site at Sparrow Way in Hersden, near Canterbury, holds much of the original Barton Hall tooling, the drawing archives, and the factory machinery. Their rebuilds use factory drawings and original procedures. A fully marinized, factory specification rebuilt 6LXB from Gardner Marine sells worldwide, mostly to Dutch barge owners, showmen, and the remnants of the British narrowboat fleet, and is the gold standard of restored Gardner power. Joe McCool at Tangent Engineering in Northern Ireland works exclusively on Gardners, the only firm in the world that does. Gardner Parts Ltd holds over 100,000 line items in stock. Walsh Engineering, where Eric Ward still works, hires former Gardner men. Marine Power Services specialises in inland waterways marinisation. Gardner Enthusiast Ltd manufactures new piston rings, valves, manifolds and major castings, including 8LXB marine manifolds. Shaw Diesels in New Zealand keeps the engines running on the far side of the world. And the workers, some, like Eric Ward, stayed in the trade, still fixing Gardners at Walsh Engineering, still applying the skills the Barton Hall apprenticeship taught them half a century ago, still able to diagnose a fuel pump fault by ear and to feel the difference between a bearing clearance that was right and one that was 1/1000th of an inch too loose. Ward started his apprenticeship in 1975, one of the last generation to receive the full Barton Hall training. He saw the golden age from the inside, watched the decline from the drawing office and the shop floor, and chose to stay with the engines after the firm that built them had gone. He is, in his way, a living archive. The skills in his hands are the same skills that Lawrence Gardner's apprentices learned on Lund Street 130 years ago. Some, like Steve Field, who'd worked in R&D and applications engineering under Gordon Parker from 1976 to 1987, emigrated. Field went to Canada to work on pumps and mechanical seals, taking his precision engineering training to a country that would use it and value it and pay him what it was worth, something that Gardner, for all its pride in quality, had never quite managed. Most disappeared into the general labour pool of late Thatcher and post-Thatcher Salford. Early retirement for the older men, the ones who'd given 30 or 40 years to Barton Hall and were in their 50s when the gates closed. Supermarket logistics for some, call centres for others, security work, warehouse packing, or out of the workforce altogether, into the long, quiet tale of post-industrial unemployment that hit Greater Manchester through the 1990s, the kind that didn't make the news because it arrived not as a mass sacking, but as a slow draining away, one man at a time, into a labour market that had no use for the skills they carried and no interest in the tradition they represented. Multi-generational employment at Barton Hall ended abruptly, and the Patricroft Sons of Gardner men generation, the boys who, in another decade, would have walked through those same gates at 15 and learned to turn a crankshaft from the men who'd learned it from their fathers, went into trades that had nothing to do with what their families had built. The chain of skill that had run unbroken from Lawrence Gardner's cellar through the Lund Street workshop and the Barton Hall machine shops to the number 10 test bay was severed, and nothing has replaced it. Patricroft itself, the canal-side neighbourhood that had defined itself for over a century around Barton Hall, Nasmyth's Bridgewater foundry, the textile mills and the railway works, became one more piece of the left-behind north. The Eccles and Patricroft economies in 2026 are dominated by warehousing, distribution and the service sector. The manufacturing employment base never recovered the depth it had in the Gardner era. The works that once gave the borough its identity, its pride and its Friday wage packet is remembered chiefly by the people whose fathers worked there and by the engines that are still, against all probability, running. Chapter 14. What the silence. Kept. The engines are still running. That is the strangest part of the story, and the saddest. The firm is gone. The works is gone. The workforce is scattered and ageing. The family name survives on spares catalogues and rebuilders' websites. But the engines, the actual physical products of 100 years of Patricroft precision, are still out there, on the water and on the road. A 6LXB in a Dutch barge on the IJ Silmere. A 5LW's driving a showman's generator at a fair in Somerset. A 6HLXB in a preserved Bristol VR, turning over at a rally in Cheshire, its exhaust note drawing a crowd of men who close their eyes when they hear it because the sound takes them somewhere they can't get to any other way. A Gardner marine engine in a fishing boat off the west coast of Scotland, still pulling, still running, still refusing to break, 60 years after it left the test shop, 30 years after the works that built it closed forever. The 6LXB's role in ordinary life was almost universally heard and almost never seen. If you rode a bus outside London between 1968 and 2000, the chances are you heard one under the floor. If you ate fish and chips made from fish landed at Hull or Grimsby or Fleetwood between 1950 and 1985, you ate a fish brought home by a Gardner-powered trawler. If you rode a waltzer at any travelling fair in Britain, you heard one in the corner of the showground. The engine was everywhere, powering everything, and nobody who wasn't in the trade ever knew its name. In 1868, a miller's son with no schooling lowered a lathe into a Hume cellar and bent the paving stones. His grandsons designed the most thermally efficient diesel engine the world had ever seen, and for 30 years, the only thing British industry argued about was the length of the waiting list. Then, one man in one Manchester boardroom decided that turbochargers were a compromise, and his nephew, the only person in the family who could see the cliff, was told to stop. The engines survived. They are running still. The firm that built them is a warehouse estate off Liverpool Road, and the silence where the works hooter used to sound has a weight to it that the concrete floors and roller shutter doors do nothing to diminish. Not through catastrophe, not through foreign competition, not through government policy or union militancy or the decline of British manufacturing in the abstract. Through one family's conviction that perfection, once achieved, need never change. Through the slowest form of industrial suicide imaginable, the refusal to build what the market needed, delivered with the quiet certainty of men who had spent their lives building the best and could not accept that the best was no longer enough.